Hi, everyone. My name is Tim Beiko, and I facilitate the All Core Devs calls, which are the calls where discussions and decisions about governance of the Ethereum protocol happen. And today, I want to take some time to talk about my view of how Ethereum governance works. It's a subject for which there's not a lot of great resources, and so hopefully going through it helps kind of paint a picture of how things are actually done on Ethereum. And as we start, I think one important thing is to define what do we talk about when we're discussing Ethereum governance. What's the actual thing that we're governing? And I think there's basically two things that we often refer to. The first is what I've called like the Ethereum protocol rules. So effectively, the Ethereum network is based on a protocol, which is a set of rules that are implemented in things like the Ethereum Yellow Paper and EIPs, or the Python specifications that we have for the network that define the sort of set of functionalities and things that a node has to do to participate on the Ethereum network. And so if you do not follow the rules of the protocols, you're sort of kicked off of the network. And that's really the main thing that, you know, when we say we're changing Ethereum or we're sort of having an upgrade to the Ethereum network, this is the set of things that are changing and that affect that. And there's some other protocol rules that I've sort of categorized as nice to haves, which are things that different clients will implement and usually try to coordinate and agree on, but it's not the end of the world if there's not like perfect match between all of this. And these are things like the APIs that the nodes expose, like the Beacon APIs or JSON RPCs, some of the gossip protocols, the sync protocols, or the way that, you know, client communicates with each other. So in practice, you know, we try to get everyone to agree to a standard here. But if there's not perfect alignment, it doesn't mean that like a node will be removed from the Ethereum network. But so when we talk about, you know, governing or changing the protocol rules, these are effectively the two things that we need. And more precisely, I think when we talk about like Ethereum governance, people will refer to the Ethereum Mainnet. And so this is, you know, the network, like the Ethereum network with chain ID 1, which has all of the balances that, you know, people consider their ETH balances. And more importantly, that has all of the assets, the NFTs, the tokens, the smart contracts and whatnot deployed on it. So when we talk about Ethereum governance, often we're concerned about, you know, what are the changes to the protocol that will be deployed to this instance of the Ethereum network, rather than, you know, something like a testnet or an L2 or an alt layer 1 that might also implement a lot of the protocol rules. So at a high level, this is what, you know, this is the thing that's being governed when we talk about Ethereum governance, the Ethereum protocol rules as instantiated on the Ethereum mainnet. And most of my talk now will be about who actually governs Ethereum and how do the different stakeholders kind of relate to each other. And I have this little diagram here, which shows you sort of all these concentric circles that kind of boil down to the Ethereum protocol. So you can think of the little image there as like, you know, the set of rules and the state that we just referred to. And there's different groups that each have an impact on Ethereum governance. And I think the closer you get to the protocol itself with things like core devs, maybe the more formal that role is. But then as you scale out, you get this more and more diffuse set of people who end up having kind of the majority of the weight and are able to kind of shift the entirety of the network one way or another, but in a less formalized and kind of more diffuse way. So we'll sort of start from the core here and make our way out. And hopefully by the end of this, you have a good view of like how governance works and how these different stakeholders kind of relate to each other. So let's start with the core devs. One thing that's worth noting is, you know, there is no true definition of a core dev. This is often something that comes up. It's really like this informal mix of client developers, researchers, and other people who contribute to Ethereum. In practice, we have over 10 client teams. So these are, you know, formal teams that build software, like the node software to connect to the network. They're spread out across a bunch of different types of organizations around the world. There's 9 of them. Their logos are on this slide, and there's a couple more as well. We have a bunch of researchers, again, from academia, from VC funds, some anons, some that work from company. The EF obviously has some as well, and so on. And there's a last kind of group of just random people who end up showing up on our Discord or somewhere else. And we've tried more recently to like force this process a bit more and bring like cohorts of new people every now and then through something called the Ethereum Protocol Fellowship. But there's really just like an open development culture, which allows people to come in and make contributions. And I have 4 avatars of like random people who showed up on Discord over the years that are worth sort of zooming in on to make this a bit more real. All the way to the left, we have Danny Ryan, which is someone who's quite well known. So he came in as a contributor on some of the very early proof of stake stuff, totally sort of, had no previous connections to Ethereum and whatnot. And today he effectively leads the research team at the EF and coordinates all of the work around like proof of stake from the EF side. So he's like a great example of someone who came in this open ecosystem, made some extremely significant contributions over the years, and now has a pretty major role. Next up, we have this like little eye avatar. This is Potiz, someone who showed up as an anon in the R&D Discord with like a lot of strong opinions and trying to like help improve the design of things. And now he's joined the Prismatic team. So he was someone who just, through coming in and contributing for a while, like ended up being, one of the core devs. After that, we have this like pineapple avatar, which is Proto Lambda. So Proto, a bit similarly to Danny, showed up to work on some of the research problems that were on Ethereum. Didn't know anyone, just came and ended up finding a lot of solutions for problems that we had on the research side. And obviously has helped with a lot of the scaling work. He is the Proto from Proto Danksharding, and now works on the Optimism team, helping to scale Ethereum through L2s. And then finally, this last avatar is probably the least well known. This was someone called Sea Monkey. So when we were doing all the testing leading up to the merge, so Ethereum's transition to proof of stake, he was just some guy who showed up and was running every possible combination of clients. So like, there's 9 here. So like the 20 pairwise combinations between the 4 and 5. He was running them all on his personal computer and just reporting bugs or UX issues as he saw them, and sort of spent like the entire time of the merge doing this. And another great example of just someone who showed up and contributed significantly to the protocol. So even though there's no like formal definition of what a core dev is, I think my personal definition looks something like this, where it's usually someone who's focused full-time on Ethereum protocol research or implementation. And by full-time, I don't necessarily mean they're spending 40 hours a week, but more that they're sticking over for a long period of time and not only focus on a single EIP or feature, right? They don't just want to come in, make a change, and then go back to their other job. They really have like a longer view over the protocol. And this means, those people will often take responsibility for, is Ethereum secure? Is Ethereum sound? Is it working as a whole well? And over time, these are the folks who like spend their time discussing and debating what changes should we make to the specs, how should we implement them, and should we potentially deploy this on Ethereum? And I think it's really valuable to keep this as a like very loose definition and have this be a permissionless group. Afri, who's like another core contributor to Ethereum, recently posted this message on a thread, I believe, around Filecoin, who wanted to make like a more closed and formal definition of core devs. And I think I agree with pretty much everything he's highlighting there, where there's a lot of value in having this be public. And on the Ethereum network, a few things we've done for this is all of the calls that have to do with not only just like the core dev calls, but even calls about specific EIPs or sidetracks, like, for example, the 444 calls or EOF calls, as shown on this image. They're all published to YouTube and live streamed, or at least made available with recordings, so anyone can kind of follow up on them. And then a lot of our discussion happens on public forums. So whether this is Ethereum Magicians, ETH Research, or we also have a Discord server. And this is something that's also very important, so that people can show up and get all of the context about something and kind of understand what's going on. So this is effectively what core devs do in the system. And they're the ones who at the end of the day, spend their time on a network, develop a client, and propose changes to the Ethereum network. but they're not the only ones who can propose a change. So we have an open process for proposing changes to Ethereum called the EIP process. This stands for Ethereum Improvement Proposal. There's a template and some instructions at eips.ethereum.org. So anyone can go and just literally copy paste the EIP template and propose a change. And a lot of people just do this on their own, especially for things that don't require protocol changes like application level standards and whatnot. You see a lot of EIPs just like being driven by the community. But I think, for people who want to make a change that like significantly affects the Ethereum network, it's a large or impactful change in one way or another. In practice, those folks will end up having to work with researchers or client implementers or whatnot, just to make sure that their change actually works and is sound and is kind of the best version it can be. And so if you sort of signed up for this role, I think as an EIP champion, what you're trying to do, trying to show that this is a valuable change, that this is sound, and won't break Ethereum. And as you're doing that, sort of creating momentum around the change to, signal that this is something that should happen and that's important. And in practice, what happens is you come up with this idea to change Ethereum. You bring it to researchers or client developers, and they'll find an issue with it. They'll find usually a DOS vector, something that could like halt or stall Ethereum. And then the best kind of EIPs will spend time to address all of these and iterate on their proposal to get to a spot where it is safe. And this is second screenshot is just a search for DOS on Ethereum Magicians, and you can see literally just from the top results, account abstraction EIPs, proto-link sharding, and then the withdrawals EIPs all have threads talking about how to deal with the DOS vectors that they would introduce. But then if you do a really good job, you end up at a spot where like, okay, you've done all these things. And one recent example I think did a really good job was the folks from Uniswap who championed EIP 1153, where they implemented it across all of the clients, wrote some extensive testing, got some like feedback from not only core developers, language developers, and also from the community to kind of show that there was value for this. And this was something where even though there wasn't like, there were still some objections, and not everybody, is necessarily, it's not necessarily everybody's favorite proposal. I think the quality of the work that they did, the feedback that they got, and then, the support that they managed to show from the community meant that it got scheduled for the next network upgrade. And this is something that took them, well over a year, I think, since the time that they started approaching this to the time that like it's actually going to get on Ethereum. But so if you have these people that like write the specs and code and write the clients, the question that always comes up is like, don't EIP champions and core devs just control Ethereum? And my answer to this is that no, they do not. So if we look at, again, our chart that I showed earlier, I think you often get this perception, mostly because EIP champions and core devs are the ones that are the closest to the actual core protocol and who have the most formalized role in the process in a way. And even maybe another way to put this is that not only is their role formalized, but it's like advertised as such. And so it's very easy to like end up with this perception that they're the ones who sort of get to choose everything. But the rest of this talk will walk you through what everybody else does and how they play a role, and why this is not the case. So first off, looking at like consensus participants, and these are usually either miners or validators. So on Ethereum right now, these are the proof of stake validators. If you have an upgrade, so say the core devs and the EIP champions agree to like a set of changes to go live on Ethereum, it's necessary for at least some of the consensus participants to run the upgrade. Otherwise, it never happens. Like the chain doesn't upgrade automatically. You need the people to manually go and change their version of the software to do this. But this is not sufficient alone, right? Because if only a subset of the consensus participants upgrade, so if you don't get anyone, what happens on Ethereum is the chain splits into two. And so there'll be people who like run the version of the upgrades, people who don't. And under the proof of stake rules, the validators on each side will just slowly burn the stake of the validators who have not upgraded on their view of the chain until those validators represent less than a third of the stake, and then the chain will keep finalizing again. So both sides would sort of, gradually destroy the ether of the validators who aren't on their view of the chain so that they can continue and keep going. But if nobody upgrades, then yeah, you don't even have this, potential risk of a fork in the first place because the upgrade's never gone live. And just to put this in practice, or numbers, sorry, as well, if you look at like core devs as an example, core devs don't run a significant amount of consensus nodes on the network. So a few years ago, we announced a client incentive program where we gave all of the client teams about 144 validators to run and obviously test their software to make sure that when we're telling everybody else to run those validators, we know it's working. So imagine, we have 10 teams, they get a 144 validators, that's roughly 1.4 thousand validators. But assume, that they had some secret validators, right? Like that they're not part of the program that was announced by the EF. Say they had 10x more than that. So you go from like 1.4K to like 14K validators. Currently, there's about 560,000 validators on the Ethereum network. So that would represent only 2.5% of the entire network. So you can imagine a world where like the core devs, single-handedly try to push something. Well, it means that like 97.5% of the network in this like extreme scenario where they have 10x more hidden validators than what is public, still they don't even get like 3% of the network. So, the vast majority of the stake is not controlled by them. And you could imagine, what if the EF sort of joined forces with them? So we coordinate a lot of these changes. So maybe we decide to do this. So the EF's balance is public. We have about 300,000 ETH. This is not staked. So we would have to activate all of this as validators, which would be public on chain, or it would, cause a delay and whatnot. But imagine we get there. Then we combine with all the client teams, we get about 24K validators, which is like 4.4% of the network today, which is still like a very, very minor share of the network. And to put this in perspective, we usually have somewhere between 97 and 99% of validators online at any given time. So it's like this scenario where the EF goes all in, the clients have some secret stash of ETH that they're creating validators with, gets you roughly like 50% more than what can be offline on a given day. So it's still like an extremely minor share of the network. And this is just, to emphasize that like EIP champions, core devs, the Ethereum Foundation can all get together and, propose a change, run it on all their nodes, but it still needs the overwhelming majority of the rest of the stake to support this change if it is to be the majority fork. But then even if that happens, consensus participants, so like the validators, aren't actually the ones who get a final say on Ethereum. And this is where we're expanding out from the circle again. So next up, node operators are extremely important on Ethereum. And this is why we spend so much time talking about decentralization and why it's important to be able to run a node and all of this. The reason is that on Ethereum, every single node validates every single transaction. And as an aside here, this like validator is a terrible term for what the consensus participants on Ethereum do because of this. It sort of obfuscates that every node actually validates transactions. So validators aren't the only one who do this. And if you imagine a world where only the validators ran nodes, then they could collude and change their protocol rules without being noticed by anyone, right? Imagine a blockchain where it's like me and one person running the validator nodes, and we're the only one who run nodes, nobody else can. Then I can mint myself, 1 million tokens, so can my friend, and nobody else is going to know that the supply changed because they can't actually scan the chain and run a node to know. And this is why it's important where the more people run nodes, the more people independently verified that the rules of the protocol were followed. And the example I gave with me and my friend is an example that's like based on malice, like we collude, we do something, but you could also imagine like an example where me and my friend are running the nodes, but we do everything right, but we have a bug because they're both in my apartment and, something bad happens, or we run a buggy version of the software. So a small validator set also increases the risk of correlated bugs. And this is something that the non-validator nodes would notice as well. And so if you have a blockchain where the non-validator nodes are abundant, then the game theory for the validators is if they propose a block that is invalid because either they mint themselves infinite ETH or they have a bug in it, then all of the network the other nodes, on the network will reject it when they see it, and they just won't propagate it. And this means this validator will have like missed their slot, right? They'll just have proposed this block that was bad. Everybody will agree that it's bad, and they'll miss the potential fees they could have gotten on a valid block. And so this is why it's like very important to run a node, because when you do so, you're effectively sharing your view of what is correct with all of the other nodes that you peer with on the Ethereum network. And this effectively gives you a say in governance, because it allows you to, protect against the consensus participants trying to like feed blocks that change the protocol rules. They don't get to like create new protocol rules and have all of the other nodes agree to them. They can only, run the software that they want, but then they need the entire network to accept those blocks. But even beyond, running a node on the network, we can think about like the users of Ethereum. And one version of this question that comes up a lot every now and then is, can a single project decide which Ethereum fork wins? Imagine, there's a contentious fork. Is USDC or is Maker or is anyone else going to be like determinant in like which is the real fork? And it's worth explaining kind of how a fork would work on Ethereum here. So if we have two potential forks, so imagine there's a proposed upgrade, some of the community upgrades to it because they want it, the other parts does not. Then at that point of the upgrade, the entire state of the network is duplicated across both sides. So every account balance, every contract, every token, NFT, and so on, there'll be a copy, like an identical copy at the fork on both sides of the chain. And for some things, this is fine, right? Like, so, the native assets of the chain, like ETH, for example, can live on both forks, and it might have just a fluctuating value. And you've seen this in the past with like ETH and ETH Classic. There's also some on-chain NFTs that, might be totally fine. If all the metadata is stored on-chain, whether the network forks, the metadata is stored on both sides, that's totally fine. But then there's some assets or some projects that actually need to make a choice because they're referring to something that's not like fully encapsulated within Ethereum, and therefore they need to choose where is this pointer going to point to. So think of something like real world assets, including stable coins, right? There's $1 in a bank. If there's two forks, they need to make a decision of like, which of those forks can redeem for $1. Or similarly, if there's an oracle that's saying like, what the price of ETH is, well, they need to figure out, like the price of ETH on Coinbase and Binance that gets mapped back on chain to Ethereum. What chain is that to what, off-chain ticker asset? And similar thing for bridges, imagine like an L2 bridge or a bridge to an alt layer 1. If they're taking ETH from Ethereum, or if they have bridge tokens, imagine like a bridge L2 token on ETH, they need to recognize, okay, which of those forks is the one that will honor a bridge asset from. And so as a whole, the entire ecosystem, like all these projects coordinating together on a fork, can like ensure that all of the assets on it migrate with minimal issue and sort of increase the odds that that is the fork that's recognized as like Ethereum. But you can't have like a single project do this, right? Like if only USDC or only the Arbitrum bridge or only CryptoPunks, were to say this random fork is the Ethereum fork, everybody else would probably just say no. But this is where, the power becomes much stronger, but much more diffuse, where if you have this like shelling point on a single chain, then it's extremely powerful and it helps kind of tilt the fork towards this chain being the real Ethereum. And you can imagine a world where like, the validators go rogue and there's not enough people running nodes. You still have, all of the projects recognizing a single fork. And this brings me to my final point, which is, quote unquote, the community, or I believe the Bankless people call this layer 0. So at the end of the day, Ethereum and a bunch of other things like Bitcoin, like the dollar, are all just a shared reality, right? They're this thing that we agree to as having all of these properties, but that can change. And we have processes, that are in place on Ethereum to make changes in like a happy case. So like in like a more formalized, everything goes well type of way. This is what we sort of touched on, the EIP process, network upgrades and whatnot. But there are there are also ways to change a network in more extreme scenarios. And these are things like contentious forks, like potentially social slashing and whatnot, where the community has to like come together and agree to what is the right outcome, right? Like if we have a contentious fork, which one actually is Ethereum? If there is like a social slashing, you know, how do we go about this? And as you have these more extreme cases, then the second order impacts become really important, right? Because it becomes a question of like, what are the values that we want Ethereum to have? You know, if we want to have credible neutrality, then, you know, is there one of the forks that like affects this to an extent versus not? If we want to have like platform stability, like if we want Ethereum to be somewhere where we expect applications to, you know, stay and be used for a long time, like, you know, is like a contentious fork or a social slashing coming at a cost to that? And there's no protocol, or there's no like clean way to resolve those things, but they are at the end of the day the more powerful, right? Like the community is like the most powerful, most diffuse things where we can all come to consensus on what is Ethereum and, you know, what the trade-off space is in a given situation where, you know, there is like an extreme case like a contentious fork or something like that. And this is possible because these systems are permissionless and open, right? Like if all of Ethereum was closed source and, you know, it wasn't possible to like actually take the code and run with that and make the change or whatnot, you couldn't do it. And one example I think that's interesting of that a bit beyond Ethereum is like Bitcoin, right? There was this big Bitcoin Cash fork. And even today, the two websites, bitcoin.com and bitcoin.org, sort of resolved to two different projects. So Bitcoin Cash and you know, Bitcoin as it's mostly known. And, you know, whatever you think of Bitcoin Cash versus Bitcoin, like the fact that this is possible, that like you can have literally, you know, two top level domains, like, or, you know, two like prime domains redirecting to like different versions of Bitcoin kind of shows you like how powerful this permissionlessness aspect is and the openness of these systems are. And you know, like the sort of resulting effects when like part of the community decides to take over and go in a completely different direction. So, you know, hopefully this gives you an idea of like who are all the different stakeholders in this and how they come together and the impact that they can have on the process. Now, I just want to talk a bit more about like some specific cases and, you know, just some high level thoughts about like the future of Ethereum specifically. So one question that comes up a lot is like, why, even if all this is true, like, why don't we feel it, right? Like, why does it feel like potentially, you know, core devs and EIP champions get to like make these decisions and like the rest of the community doesn't quite get a say? And my answer to this would be that if core devs are doing their job well, then they'll listen to the community and they won't push forward a contentious upgrade. And they have an incentive to do this because if they push a contentious upgrade and have to deal with, you know, all of the messiness that comes with a contentious fork, they're the ones who actually have to like write the software for all of this. And so the cost of like dealing with a contentious fork is very much borne by these people. And that I think helps like make them hyper aware of, you know, not pushing anything that might lead to this. And if you look in practice, like in Ethereum's history, I think there were four probably big contentious cases. And, you know, I'd say probably more three, and the fourth is more of like an extra example. But definitely the most contentious one was the DAO. So this was very early in Ethereum's history, about like a year after Ethereum has gone live. There was a hack which had 15% of the ETH kind of affected by it. And there were a lot of differing opinions about how should we approach this. You know, should we recover the funds? Should we not? And in this case, what core devs did is they put out software which allowed users to signal whether or not they wanted to run this upgrade, which would return people's money. And so this was, you know, I think a pretty neutral approach. And then most of the community sort of rallied around on reversing the hack, and a small part of the community didn't, though, and this is where Ethereum Classic comes from, right? The sort of the version of Ethereum where this hack happened and, you know, was not changed after the fact. But then a couple of years after, there's another big hack or a bug actually on the second most used on a multi-sig, which was written by the Parity team, which had the second most used client after Geth and was also led by Ethereum's co-founder, Gavin. So it literally made all of their funds stuck, as well as I believe it was like 100 other projects funds were stuck. And there were a couple of EIPs to resolve this, most notably EIP 999. And this got a ton of community opposition. And so even though this was proposed by literally like one of the co-founders of Ethereum, it was one of the, the second most used core dev, the second most used client. So like, a very central core dev team. The rest of the different client teams never sort of agreed to propose this in an upgrade due to the community opposition. So this was even like a more conservative stance than was taken with the DAO. And then after that, another EIP that came up was EIP 1057, also known as ProgPow. So this was a change to how Ethereum's proof of work algorithm works, where Ethereum has always had this goal, as stated in its yellow paper, to make the network ASIC resistant, so to not end up with like basically private companies building hardware for it and be more accessible to GPUs. We saw this starting to change, so people proposed an upgrade to the proof of work mechanism to try and retilt things towards GPUs. And there was a lot of community pushback against this as well. And I think this is something where it's hard to say exactly, but core devs were probably like weakly in favor of it. But seeing the strong community pushback led them to not put this in an upgrade. And so ProgPow also wasn't ever shipped. And then my last example is a bit different, but the merge, right? Like Ethereum's transition from proof of work to proof of stake. This was part of Ethereum's, quote unquote, roadmap since the very early days, in as much as there is a roadmap for Ethereum. There was obviously pretty strong community support, and it's worth noting that like the Ethereum Classic fork that resulted a few years ago, I think helped move a lot of like the very pro proof of work people to a different community. But miners were obviously very opposed to this, like we were taking away their entire business. So this is an example where, the client teams clearly pushed forward and proposed the upgrade. I'd say the overwhelming majority of the community transitioned, but there is like this tiny minority fork that's popped up around the time of the merge, Ethereum W, and I believe it still exists today, although it's not like maintained much. But it is, an example of like part of the community was able to opt out of this and keep doing their own thing, even though the vast majority kind of moved in one direction. And I think that assessment is what led to core devs, feeling comfortable pushing the software, knowing that like, there'd be very minimal parts of the community who thought this was contentious. So with all this said, it's worth maybe giving a high level recap of like what's good and what's bad about Ethereum's governance structure. One thing, that's great. It's like permissionlessness. Everyone can participate in it. You don't need to ask anybody. You can just sort of show up and contribute. But one downside of these types of structures is, best encapsulated in this as the tyranny of structurelessness. So it's much harder to like make changes and affect actual change in a structure like this. So if you haven't read this essay, I would recommend it as a good view of like the failure modes of something like this permissionless governance. Another pro is that it is a capture resistant process. So because the process is very informal and malleable, it means that if it tries to get captured or attacked, we can sort of change the rules of the process quite easily. Where if there was, like a very formal on-chain structure that, you have to do X and Y and Z to get an upgrade, then you're sort of telling people if you do X and Y and Z, you can capture the protocol. So because we have a vaguer process, I think this helps be more responsive. But this comes with the downside that like, if you don't know about the process, it's extremely hard to navigate and you need to build up all of this context to be effective within it. And then lastly, there are several checks and balances. So as we went through this entire kind of onion of different stakeholders, these are all effectively checks on one another, which is very valuable because it means one of those groups can't like unilaterally change things in one direction. But this means that when there are contentious issues, it's really hard to gauge what the community thinks, right? Like what's the consensus here? How do we weight different stakeholders? There's no formal way or like unique way to do that. And so yeah, I'll wrap up with some of my thoughts on like, where we're going from here and sort of what I've seen over the past couple of years. One thing I think is interesting is there's more and more people who like have a seat or want a seat at the table. There's a lot of teams that are not only like affected by changes to Ethereum because they've built businesses or protocols on it, but that also want to help shape things. So like L2s, infrastructure, major dApps, we mentioned Uniswap earlier, they sort of want to contribute. So there's many more people who like get involved in this. And then in parallel to that, a lot of the easy stuff has been done. So I have this high-hanging fruits, I guess, phrase where most of the low-hanging fruits have been picked, and a lot of our new proposals like have trade-offs, and you can have reasonable positions on both sides of those trade-offs. So it's much harder to like say, oh, this is the obviously right thing and this is the obviously wrong thing. And so if you combine those two things, right, like if there's more people you need to align and like more difficult trade-offs, I think it does make it harder to move forward, right? Like it slows things down by default. And add to that there is more at risk because there's just more value like built on Ethereum. There's more applications, more things we don't want to break. So one big open question that I have is like, does this lead to ossification by default? Does this mean that over time it just gets harder and harder to change Ethereum? And at some point it's like so hard that like you literally can't. And I don't have an answer here, but it's something worth thinking about. And a few things that myself and others have been trying to do to help make things, I'd say, a bit better on the governance point of view in the past year or so. One is just aligning how the specifications are done on the consensus and execution layer. So since the merge, those things technically are the same. Or talk to each other, but they have like very different processes. So trying to get that to like a single process to make it easier for people to understand changes that are being proposed to Ethereum, and also to propose a change themselves if they want. So that's work that's been in progress. The other thing is I think more and more trying to use like async forums like ETH magicians to gather feedback, to like signal changes that not only like are a bit more open to people coming in whenever, but also like less ephemeral than things like using the calls or agendas for the calls, which are extremely hard to then dig into. And then this is a bit more of a wild bet, but the EF this summer is funding this initiative called Summer of Protocols, which basically is funding 30 researchers from a bunch of different domains, from healthcare to like the environment to like some blockchain and tech stuff, to think about protocols generally, some of the hard questions about them, and see if we can come up with better mental models, better frameworks to address these. And then lastly, I'll leave you with some stuff I don't have an answer for, and that's kind of on my to-do list. So balancing, speed versus stability of the network, kind of related to my previous slide. But if we know we're going to ossify, we should probably go quicker. But if there's more at stake, we should probably be more careful with how we approach things. So finding the right balance between those two things. I think similarly, we have this big focus on L2s on Ethereum. This is the way we see ourselves scaling the protocol. So what should it look like for L2s to standardize? Should they try to come to L1 or through L1 governance for some of that process? If so, which parts? What does that look like? And is there a trade-off? Like, if there's too much standardization, then it's kind of useless to have many L2s. You want like a diversity of approaches, but are there some things that are worth, unifying or potentially even enshrining in L1? And then my last big open question is like Ethereum governance works, mostly like the formal process works mostly through like these calls that we have. Can we do even more to move things async and have less of a focus on that? The good thing about calls is they give us a lot of momentum, but the bad thing is, they optimize for people who can like show up on the call, speak in English, think on their feet and whatnot, which is not necessarily the set of things we want to optimize for long-term governance. So how do we like slowly transition that over? And so, yeah, that's all I had. Thank you so much for listening. Hopefully this was helpful and kind of helped you understand a bit how Ethereum governance works. If you have any questions, you can reach out to me on Twitter. I'm at Tim Beiko, or feel free to email me. I'm tim@ethereum.org. And yeah, it was nice presenting this to all of you. Cheers.